In the birch reduction, we have the first application is the conversion of what aromatic compounds or arenes to 1,4-cyclohexadiene or partial reduced, one can call it a partial reduction of arenes. And we have the reagent, metal, liquid, ammonia. This is the first application in the birch reduction. Second, now we'll moving to the next application of, and here the two important things should be there. For what simple benzene, so there is a very one can say similar mechanism is there, but this is the first general example for what aromatic ring. But if any donor or withdrawer is there, then there is a change in the formation of 1,4-hexadiene. So this is the structure where donor is there. Now here, this is for what? The withdrawal. Okay, this is the regio selectivity in the birch reduction. Okay, and here simple, this is birch reduction. So what? Application of that, particularly the birch reduction, a conjugated compound is going to convert into isolated one. So conjugated olefins to isolated alkenes. Now how this mechanism and how this reactions are going to be takes place now. The general condition here, this is suppose example my diene. Okay, this is what diene, and that diene is going to convert into the alkyne. Oh, sorry, alkene. Okay, here this is conjugated. First is a conjugated, and this is what isolated. Now how this will be a proceed now. This is the second application in the birch reduction. Now as you know that this is what the double bond, and I am going to react with the metal. In your solvent is liquid ammonia. So here metal gives the electron to the double bond. This single electron is going to be react, and this double bond is cleaved homolytically. Okay, this is one electron, this is one another electron. So what will happen now? This is the double bond, and here we are adding one electron to this double bond. So this should be a radical, and this should be a negative charge. Okay, that means it is again called as a 1 to 1, 2 radical anion. That 1, 2 radical anion is unstable because they have both charges are nearer, both electrons are nearer. That's why they undergo the repulsion. So adjacent to the radical, the bond will be cleaved homolytically. And if bond is cleaved homolytically, so you will get the more number of radicals. And these two radicals are going to make a double bond, and these are the two like this one, and this compound is a 1,
One four.
4 radical anion. And later on, you know the remaining things. In the next step, what happened? We must provide the proton.
Yes,
First, we'll
obviously.
provide the proton. This will take the proton. So structure becomes like this. We have this is a radical. Then that radical is going to react with the
Yes.
metal in the liquid ammonia as a solvent. Okay, so it gives the electron to particularly to the radical. That radical is going to convert into the now negative charge. And further, by the use of what any proton donor, okay,
Oh, yes.
so that negative charge is going to neutralize, and finally you will get the product as a
Isolated.
isolated. Okay,
Yes.
so
Yes.
this is the mechanism for the conversion of conjugated type of a molecule to the isolated one.
Isolated.
We have various examples. First, there is a formation of 1,2 radical. It isomerized to 1,4. Okay, and finally proton extraction. And then further reaction will give rise to your product. So we have various examples. Look at this example. Find out the product of this. Okay. So here carbonyl compounds, simple carbonyl compounds are going to convert into the alcohol. Uh, Third application of that reaction, carbonyl compound to alcohol. Okay. So here, you know that very simple example. Suppose we have a aldehyde, it going to convert into the primary alcohol.
Yes.
If we have ketone, it going to
Second.
convert into secondary alcohol. As
Second.
the applications we are already discussed. But what happened now? What type of the mechanism is going to be proceed now? We'll first discuss, and then we'll see the some examples. Here, this is what carbonyl compound. This is what your carbonyl compound, and we are going to add that metal in what liquid ammonia. What happened now? This metal gives the radical to that carbonyl carbon, and here this will be like the radical anion. And there are possibilities are there. It will dimerize to form phenol, etc. But if you directly add the proton, if you directly add with the proton, so it becomes uh, this radical, and finally what? Here metal in liquid ammonia. This is the first part, and second part is what H plus. So that will give the your product as alcohol. In this way, we get the product. But what happened when we have cycle, which is going to add it like this fashion? Okay, and in generally, what happened now after giving the electron, so there will be formation of at a intermediate. Now look at this what type of the intermediate is there now. Now here, if this metal gives the electron from this side or from this side, which will be the most stable now? Example, if this is the A root now, if this is the A root, that means this will be the O negative, and here uh, this will be the my radical. Okay,
Hmm. Yes.
yes or no?
Yes, sir. Yes.
And in the B root, what happened now? This is my radical and this is my O negative. Now which will be more stable now?
Sir,
On which
first,
factor we are going to decide? This is what there is a confusion is there in the first example. We have to also write the this product too. Now look at this in first instance. Okay, I'm talking about this example. Huh? So we'll get the first
equatorial
intermediate
रहेगा
there.
क्या?
Your bulkier group should be on equatorial. And which is the
So O
bulkier now?
negative. O negative. Oxygen.
Yes, O negative. So here this
O
O
negative.
negative is on equatorial and this O negative is on
Yeah.
axial.
Axial.
Your first one is an axial. And here this O negative and this tertiary butyl makes much more crowding. That's why this should be a your minor. This should be a your minor. And this should be your yes or no.
Yes, sir.
Okay.
Major ये वाला,
And
second वाला major.
if
Yes.
you add an H negative and for example any nucleophile, which will be a major now? If you are adding any nucleophile, so nucleophile always prefer A pathway, A. Any nucleophile prefer the A route.
Yes, sir.
But here we are adding electron, so the second one is a major one, and that's why after the protonation and all these things, so you will get the product is this one.
OH is on equatorial.
Okay, and similarly, what
Yes, sir.
in the first case also we have to follow the same mechanism. Okay, so we have to also
Yes, sir.
follow the same mechanism here. Here also we have to obey the same mechanism. But just understood or remember this example, you will find what any kind of you can solve any kind of the example if you know just one.
सर न्यूक्लियोफाइल रहा तो वो फिर वो एक्सियल जाएगा कि इक्वेटोरियल रहेगा?
No, nucleophile always prefer the stake a least crowded side. So here A is a least crowded side. A root is least crowded one. Okay, while B is a more crowded one. We are adding the electron, no issue, but we are deciding the product on the basis of its stability of intermediate. Our bulkier group should be on
इक्वेटोरियल. इक्वेटोरियल.
equatorial. That's why your major should be the second one. And based on that, we have the second product is a major or the this is a major product. Okay.
Yes, sir.
Okay, fine. Then the next application of that same reagent, that's fourth application, reduction of conjugated carbonyls. The fourth application, reduction of conjugated carbonyls to either conjugated carbonyls are converted into saturated alcohol or saturated ketone. Very important application of. Now look at this. This is my starting material now. This is called methyl vinyl ketone. When methyl vinyl ketone is going to treat with the metal and liquid ammonia, it will going to form a two product now. What are the products will be developed now? Either it will give saturated carbonate or saturated alcohol. So these two products are expected from the metal in liquid ammonia when it is treated with the conjugated carbonate. We have one more example for this. Suppose I have the molecule is this one and I am going to react with, you will get the two kind of a product. It depend upon type of, this is a one, so these two products are based on, here this is metal is equal to either lithium or sodium. Here also what metal is equal to lithium or sodium. But here again in the presence of liquid ammonia, this is also common. But the role of solvent is very much important now. If you want to prepare the saturated carbonic compound, then you can use the ammonium chloride. And if you want to prepare the saturated alcohol, then you will prefer the ethanol as a solvent. So here just the role of solvent decided the type of product. Okay.
Yes.
Remaining all these things are same. Now whatever the mechanism is going to proceed now here. So we'll discuss the one mechanism here. Suppose this is my conjugated carbonate and I am going to react with metal in what? Liquid ammonia. And you know the chemistry. Metal gives the electron to, now this metal is going to add on the fourth position. So what happened now here? This will be a, so if I add that electron to here, so it will cleave the bond and you will get the negative charge at here and radical at here. Then next one, it is 1,2 radical anion. So this bond will be cleaved, this one homolytically, and it will form O negative, and here this one. No, we are not getting like that. Okay.
No,
so,
negative नहीं होता है ऐसा.
Okay. So first of all, what happened now? So here, this is what I'm adding that electron. You will get radical anion. Then further, I'm breaking that bond now. Further, I'm breaking the bond. So basically, what happened here? Yes, this will be the radical, and here this is the negative charge. Okay.
Yes.
So you will get the 1,4 radical. Now here the negative charge should be on oxygen because oxygen is more electronegative, no?
Yes.
Then that means we have to make or we have to prepare. If I add the radical, then this one. No. Okay, right. You get the 1,4. This is what 1,2 radical anion. This is 1,2 radical anion, and this is what
1,4.
1,4 radical anion. Now what happened here? The next step is what?
Metal. Metal देगा electron.
You're adding what? The negative charge and etc. And here, so here this will be the OH by certain reactions. Example, by adding metal and etc. And this bond also get neutralized. That means here are simultaneous three reactions are there now. Which three reaction? First is addition of metal in liquid ammonia.
Yes.
Okay. Second one is a H plus ion.
H
Okay,
positive.
no, H plus. So either you add in a first step, you add the H plus ion. So this O negative is going to neutral. This carbon negative is going to neutralize first. Then we are adding what the metal. This radical becomes a negative, and then H plus ion. So you get the enol. You get the what? Enol. And enol is further converts into here. Look at the reaction. This is what the enol now, and enol is going to convert into the keto form by just the keto enol tautomerism, like this. And if this is what the role of what ammonium chloride, that is an aprotic and non-polar solvent is there now. Okay, that means aprotic. And if I use that ethanol, then further reduction of CO is going to take place. So this is the mechanism for the preparation of saturated alcohol or saturated carbonyl compound in the presence of ammonium chloride or etc. Okay.
Yes.
So we'll discuss some examples related to that. So sometime the question is that this is a conjugated carbonate and how to prepare this molecule. Okay, and again how to prepare this one with the help of the same chemistry, that is Birch reduction. So what happened to the first skeleton now? Look at this reaction. So this reaction first give rise to the enol, right?
Yes.
Okay, this give rise to the enol. Enol is react with RX. How this one, how the proceed is now? How this will be proceed? This will be like this, and this double bond is going to attack onto the R now. So you will get the product. Okay, and in the presence of what, for again H plus ion, in the presence of what, H plus ion, this molecule is going to again convert into the enol. Okay, and we have what, RX. We have what, another RX, R dash X. So will be like a reaction, and it's going to attack onto the R. You will get the your desired product. This is the alpha alkylation. This is the alpha alkylation. This is called as a alpha alkylation, and further alpha alkylation give rise to your dialkylated product. Okay.
Yes, sir.
That means always there is a question in the Birch reduction, because there are various applications are there. Okay. So example, I have 2-methyl. Suppose I have, this is my reactor now, and I want to prepare 2,2-dimethyl cyclohexanone. So how can I prepare it now? Again by the application of the Birch reduction, that is lithium in the liquid ammonia as a solvent is a NH4Cl. So first of all, what happened here? So it's going to convert into the reduced form. You will get the enol, and that enol is going to react with RX now. RX or simple methyl halide. So you will get the product. तो यहाँ पे आप कोई भी इलेक्ट्रोफाइल ले सकते हैं. Example, if I am reacted with the DMF, you know the DMF. Look at this reaction now. Lithium in liquid ammonia, and NH4 is a solvent. So in the presence of DMF now. Now, what is the role of DMF now? Here, DMF is nothing but the dimethyl formamide. This is called as a dimethyl formamide. So the first step is formation of enol, and then I am going to react with the DMF. DMF is one of the best reagent for the formylation. That means it gives the formyl group, this one. So this group can be substituted at the alpha position. What will the product now? Instead of alpha, you will get, okay.
Yes.
And if I react with any aldehyde, example formaldehyde, then what happen? It give rise to the alcohol as a product. This one. The very simple chemistry is there, because you know that this will be your enol is also be act as a nucleophile. Like here, this bond will be free. Here also the same chemistry. Okay.
Yes.
So this is the fourth application of your Birch reduction. And the last application, that is conversion of alkyne to E-alkene. And that's why this is an E-selective or the stereoselective reaction. Now very simple reaction. This is what 2-butene is going to convert into butene in the presence of a metal in liquid ammonia. Now we are interested in the mechanism portion. So how is going to be proceed now? So here this is what my triple bond,
Okay.
okay, and I am going to react with the metal in liquid ammonia. What happened here? This metal is give the electron to the pi bond. This pi bond will be cleaved homolytically and form the. So look at this. This is what we have, the double bond, and these are the two methyl groups. Now we have the charges. This is what radical, and this is what negative charge. This is called 1,2 radical anion. Structurally, there are two things are possible. One is this, second is this one. Now, which will be a very stable?
Trans.
Yes. Okay, because here 1,2 anion, they cannot be converted into 1,4. There is no possibility to make 1,4. Then how they will be arranged? They arrange itself in a such a way that the electron and the radical, the negative charge or the radical, they should be opposite. So this is called as a cis, and this is called as a trans.
Trans.
So cis will give rise to the minor product, and this is an unstable, and trans is what? Stable. And here this will be used to the major one. That's why by the protonation and by all these reactions, you know the remaining things. So you will get this is a major product. But there is some question in that. Okay, anyway, acyclic, this is an acyclic molecule. Okay, always you get the trans. But if you have cyclic type of a compound is given, suppose this is an cyclic is given. Now in that case, we cannot change the stereochemistry. Okay, right? That means you will get the product is this one, cyclooctane. So from cyclooctane to cyclooctane.
Cyclooctane.
Okay, this type of the chemistry is done. So cyclic is there, it will be converted into the cis. This is the one can say the application behind this one. So what happened is sometime there is a question is there now. Example, we have two types of double bonds are there now. One is the internal double bond. This is the internal double bond. Okay, and this is what the here R is an side chain is there. Again, more carbons are there and etc. Now the question is, what happen if I am adding the liquid ammonia or I'm adding what NaNH2 now. This NaNH2 is one of the stronger base. So it will going to take the proton first. Okay. And if proton will be abstracted, then this will be the your structure now. Now we have two types of double bonds are there now. This is the electron rich double bond because we have negative charge, and this is the electron deficient. That means if I am adding that liquid, so lithium in liquid ammonia, then which double bond is going to be reduced now?
Electron
Internal
deficient.
double bond will be going to reduce now because it is electron deficient. So here it will be going to convert into the structure like this. And by the protonation of that molecule, resultant alkene will be like this. Okay. So whenever we have two types of a double bond, if internal and terminal. So internal triple bond will going to reduce first, then what the terminal triple bond. So this should be keep in mind. So these are the applications of and reverse to that of this one, conversion of conversion of what alkyne to E alkene. If you want to prepare the Z alkene, then we have Lindlar catalyst. If you want to prepare the Z alkene, then we have Lindlar catalyst, that is palladium calcium carbonate, and this catalyst is called as a Lindlar's catalyst. Okay.
Yes.
So this is what the first your reagent, that is called electron transfer reagent. Now we have similarly two reagents are there. That reagent is called as a metal in acid reduction. Metal in acid reduction. Now what is meant by metal in acid? That means we have a metallic solution, and metallic solution is what? In acid. And in that we have the best example is the Clementine reduction. We have what? Clementine reduction, and Clementine reduction is nothing but the zinc amalgam in HCl. Now amalgam is a type of solution in which mercury is binded with the metal. So we have sodium amalgam, we have potassium amalgam, we have zinc amalgam, etc. So here we are using the metal and the condition is acidic. So that's why it is a metal in acid type of reduction. So there are some limitation to this type of a reduction here. So because of the presence of acid, the acidic groups if present in a molecule, that can be affected now. So acidic group affected means if a molecule is there, a carbonyl compound is also there, and along with that some ether are there. Examples are ethers, acetal, ketol, etc. Okay, and because of the presence of an acid, there is a chance of what migration, there is a chance of what rearrangement, chance of rearrangement. And one more important thing is that, so high molecular weight carbonyl compound can't be reduced. High molecular weight, example steroid carbonyl compound can't be reduced. So these are the three limitations behind the Clementine reduction. Now what is Clementine reduction now? This reaction is used to remove the oxygen. This reaction is used to remove the oxygen. That means this is the type of what, look at this. Okay, and here we are using the metal is a zinc in combination with mercury, and here this is an acidic medium. Okay, now oxygen removal reaction is this. This is the oxygen removal reaction.
Removal.
What are the limitations? Acidic groups are affected. Example ether, acetal, ketol. Okay, there is a chance of a rearrangement because of acid, maybe chance of a cation formation and cation undergo the rearrangement. High molecular weight carbonyl compound cannot be reduced. Example steroid. Now what will the mechanism behind this reaction now? So look at this one. This is suppose my carbonyl compound. I am first going to react with H plus ion. What happened now? What happened? So this oxygen have the pair of electron. Take the proton first. So you will get the this skeleton. In the next step, to satisfy the deficiency on oxygen, this pi electron is going to move on to the oxygen now. What happened now? Here you will get the OH, and the charge will be the positive charge, right?
Yes, sir.
Next to that, what happened now? Now next to that, I am going to add further H plus ion, so it becomes a converts to alcohol. Next, further I am adding H plus ion, so that H plus ion, sorry.
Protonate.
So here, what happened now? Instead of the proton, this is the positive charge now. And now the positive charge is going to react with zinc. So zinc is a 2 electron donor. It is a 2 electron donor because it has the valence configuration is 3d10 4s2. So these 2 electrons are directly donated to the cation now, and that cation means 6 electron, 6 plus 2. How much? It is 8.
8.
Now that 8 electron is nothing but the negative charge. 8 electron nothing but the negative charge.
Negative.
Now the negative charge is going to neutralize by H plus ion. So what will be the next step now? OH. We get the alcohol. Now I am adding H plus ion because this is an acidic reaction. So where acid is there. So here this OH is takes the proton will be abstracted. It becomes converts into the OH2 plus. OH2 is one of the better leaving group. It is leave from the molecule, and if it is leave from the molecule, it converts into the cation. And now that cation is further react with zinc. It reacts with now zinc. Zinc gives the 2 electron to the cation, and that cation becomes converts into the negative charge. The negative charge will going to neutralize by H plus ion. So here this is the one hydrogen, this is another hydrogen. Now what is the role of mercury now here? After giving zinc, after giving electron by zinc, so zinc converts to zinc dipositive ion plus 2 electron, right? And here 2
Yes.
electron transfer reaction is there now. So 2 electron is here and 2 electron is here. So total it is a
4 electron.
4 electron transfer reaction, right? 4
Yes.
electron transfer reaction. And in this case, somewhere cation is there, somewhere anion is there. Look at this one. This is carbanium. This is what? Carbanium. This
Carbanium.
is carbocation.
Cation.
Means here both
Carbocation.
both intermediates are be formed. That means cation and anion will be formed. So total it is a 4 electron transfer reaction. What is the role of mercury now here? The mercury stabilized to zinc plus ion, zinc dipositive.
Zinc.
So here Hg
Zinc.
stabilized to zinc dipositive ion. And this is the what mechanism behind the Clementine reduction. And already we discussed the mechanism example. Okay.
Yes, sir.
So this is about the your electron transfer reaction. One more is remaining here. That is called non-metal electron transfer. Okay. So non-metal means what? There is a one special reaction in the family of what non-metal, and that will be called as a Wolff-Kirchner. Wolff-Kirchner reduction. Now, what are the reagent are going to be used here? So here hydrazine, that is NH2 NH2 in alkali. That means it is a non-metal basic medium type of a reduction. What type of the reduction? It is a non-metal, because we are not going to use any metal here. Non-metal and
Basic type.
basic medium reaction. Basic medium reduction. One can say the reduction. Here there is a no acid level groups are going to affected. No rearrangement. Okay. And one more important, acid level groups are unaffected. Important one thing is there, used for high molecular weight, used for reduction of
High molecular
high molecular
carbon
weight
complex.
carbonyl compound. What is the simple reaction behind this? So here this is my carbonyl compound and I am going to convert into this hydrocarbon. Again it is an oxygen removal reaction in the presence of what hydrazine. This is NH2 NH2 and in the presence of what base.
Yes. Basic.
Now look to the mechanism behind this reaction. So mechanism of this reaction, first you take the carbonyl compound and is going to react with hydrazine now. This is a simple condensation type of a reaction with loss of water in the first step. It will form the hydrazone. What is hydrazone now? This compound is called as a hydrazone. Now I am going to add the base here. Strong base is there. We are going to take the proton from the NH2 from what? NH2, so it becomes a NH negative one. The next step is what? Resonance. it undergo the resonance, and here a negative charge is going to be like this. So you will get the charge at here. This is what N double bond
Double bond
NH.
NH.
What happened here? This is what negative charge
Negative
like
charge.
this. Further, this is abstraction of the proton by the base now. Okay, and here
Yes.
if this negative charge is going protonated first, then what happened now? Your N double bond NH is there now. Okay, and the important thing in this reaction is what? We have to remove the hydrazine. We have to remove the nitrogen gas.
Right.
Okay, so because you know that here the byproduct is your, which is your byproduct now? Your byproduct is
Yeah.
N2, which is a good living group.
Good living group.
So first, just I am adding this reaction and etc. Okay, you will get the product. Finally, what happened to that? So first, I will do the protonation to the molecule. It will give rise to my skeleton will be like this. This will be N double bond and NH. Okay, here I am adding that your H. Now next step is again I am going to add the base now. So base is going to take the proton from the nitrogen.
Right.
This is what N double bond N, and this is negative charge. Now look at the last step here. This negative charge is going to make N triple bond, and this the bond is going to on carbon. So what happened now here? So here in this case,
Carbanion.
when the molecule is free, and you will get the carbanion as an intermediate.
Carbanion.
And you know the next chemistry is there. This carbanion is going to protonate it using that any acid. You will get the product. Your product is hydrocarbon. So this is the carbanion chemistry. Only one intermediate is there now. This is called the carbanion as an intermediate. No rearrangement, nothing is there. So very simple chemistry. Okay.
Yes, sir.
So this is all about your electron transfer type of a reduction. First step is simple addition of hydrazine, then proton transfer, and then elimination of N2, and finally again protonation. So likewise you will get the product. So we'll stop here. This is your second reduction, second category of reduction. We are finished here, and the last one will be finished in the next lecture. Okay.
Okay, sir.
Yes.
Okay, fine.